Let's come to the next part, to the CODESYS profiler. The profiler is a tool which helps to measure the application performance. So really like a watch clock, like a lab, in order to check how long every object takes. Why should you do that? It gives you important information at first step for the selection of the right sized controller, if it's not decided yet. Or on the other way around, you can check whether the loads created by the application is too high for the controller. Or in case you have already defined or limited controller performance, you can check whether the code fits inside. And you can check that not when you want to start commissioning, then it's probably a little late, but you can do that during your development of the application. So therefore, such a measuring gives you extensive information for validating the application software. So it reduces the analysis time when you use integrated measuring options, and it helps to reduce the regression tests thanks to early measurement in the development phase. Now, how can you do that? Quite simple, work with timestamps. And I can show you that without CODESYS profiler. Perhaps I close all editors. I have here an option, or here a POU, where I do exactly that. I call a method that gets the system time stamp from the controller. This is no miracle. It's a L time, and just getting L time and storing it somewhere gets the system time in nanoseconds. So very accurate. Of course, depending on the controller. In my case, it's a PC I'm working with, that therefore it's nanoseconds. You can do that at the beginning and at the end of each POU. So as I do it here, perhaps we delete these messages from the application, from the static analysis right now. Yeah, you see, I can do that at the beginning and at the end, and can calculate something. And then I get the time for the application execution, for the object execution. Quite simple. Now, when working with such a bigger object or bigger project, I will have to do that multiple times. And all this additional code, of course, changes the timing behavior of my complete application. So therefore, at the end, I don't want to have that code inside. Therefore, I could do something like that. Here, you see, I've put in a pragma, reminding me to delete that code again for the final version of this application. This could be a way without a tool like the profiler. However, doing that multiple times, this could be annoying. So therefore, you can use the add-on tool, the profiler, which is something like that here. Yeah, maybe you know the profiler from TV. He's somebody who really checks around and gets the right information in order to solve a problem. There's a question, how do you get the controller first cycle scan flag? Is there a system level tag for do this? Just give me a few minutes. I will talk about that in a minute. Okay, so the profiler tries to check the code in order to find information on the performance. And how is that done in CODESYS? So switching back to the CODESYS development system. At first step, the profiler is an object that is implemented into the project tree. And those of you who have already the older version, this might look different. Therefore, again, update, and then you get the newer version, which is here inside the object tree. Otherwise, add object, and then I will find it in here. You cannot find it in here right now because I've already added it, obviously. There is only one profiler per application possible. And I have already edited it before because I wanted to show you something about snapshots, which you will see right now here. So you've seen yesterday, I've already worked on that project and did some snapshots, whatever this is. Okay, at first step, we can define the method for profiling. So coming back to that method here, where I add some code in order to measure, this method is called instrumentation, and you will find the same method in here, instrumentation. Going to the settings dialog, you will see that I have now several options. At first step, I need to define the task in which this code should be checked. Then I can, it's an option, define whether there's a condition with which the profiling should be started, or if it's started immediately. Then I can watch the first cycle, and this is the question you have just posed in. With that option, I can be sure that the first cycle is included in my watching, in my measurement, or I can exclude it as wanted. Then I can define whether I want to instrument the whole application, so all objects should receive that code at the same time, or only some of them. So if I deactivate that, then I can decide whether only some of these are measured or just activate all of them again. Then I can define the recording mode. I can always just record the next cycle where I am, or the max cycle within a time period, and the buffer size. And then I can show the snapshot appearance in milliseconds, microseconds, or in microseconds, or in ticks, or whatever you want to. But it has shown milliseconds, microseconds is just not bad so far. Okay, as soon as I have activated the instrumentation, I will see here in the status line of the CODESYS development system, a red information profiling is activated. This is an important information. Remember what I said a minute before? This instrumentation causes additional code, and this changes our timing behavior. So be sure when you work with the instrumentation that you switch it off before commissioning the machine and take the final version of that code. So now we can log in with the profiling activated and start the measuring. This is something that should not happen, but it may happen from time to time. So I can switch out, make a clean all to be sure that everything is clean and empty. And then we log in again, generate the code. And this time with this additional instrumented code, which realizes the measurement. And this means that this code is really running on your target controller. In my case, it's a soft PLC running on the PC, but in your case, it will be probably any physical, any dedicated controller. So there's a question in the meantime. My question was how I determine in my POU programmatically for the first scan to run a certain piece of code similar to other competition like Schneider or Rockwell. Yeah, if you do it the manual way, you can do that within the application, have any counter and do it like that. With a profiler, you don't need to care about that. You can do that and check it using a special counter, which just runs through the first time the code was executed and then set it to a certain value and then check whether it was executed before and then skip it in case you do not want to measure it anymore, or you just take the profiler where this is done automatically. Okay, now let's start the application. And we get immediately a measurement. So we see how the cycle took in general. We see the main task. We see the PLC PRG, which called some POUs, and we can look inside them and see at first step how long it took. And we see as well how often they were executed. So this means, for example, when talking about the optimization of the load, we should check those POUs first who are executed quite often. So I could directly jump into that POU and see what is done here. Maybe I can do something. In this case, it's quite ridiculous, but however, it could be a more complex thing. And I could start my optimization there because being called so often shows me that it's worth to work there. Yeah, and you see all these measurements immediately. I can now refresh that snapshot, get other values in a later state of the application. I can save that snapshot. So for example, development day 2, give a certain description, say okay. And then of course I have that values available in here, that list of snapshots. And this is a good recommendation. Make a snapshot at the end of every development day. Then you can check and see where was perhaps a jump in the measured time in a certain object. Perhaps there was some error that was unintentionally entered into that code, which you can then very precisely find and debug and check. Yeah, and of course I can reset that values and measure once again as often as I like to. Okay, so this was that instrumentation. I forgot to show you something more. There are some more trees, categories here in the tree. So I have an overview, which is as well saved in the snapshot, by the way, which was the project, the timestamp of the measurement, which was the number of instrumented PUs, the cycle, which has the maximum cycle time, and some further, global information. And instead of having that call tree, we can as well have a backtrace, which is just the opposite round. We see from bottom up. Simulation was called by main task by cycle. For example, this is more interesting. The polling was called by aux PU. This was called by PLC PLG and so on. And you can further the track in the other way around. Or you just go to the list view and sort by the PU name, by the timing, which is the standard sorting, by the average, minimum, maximum time, and so on. What you can even do is you can get some more information. No, you can do that here. You can get some properties of such a PU and perhaps save these information too. Okay, so let's go back to the methods. This was just one method, as you've seen. There are two other methods. Sampling. Now, what is the difference? As I said, with instrumentation, there's additional code put in the objects of my project, which changes the behavior. In some cases, this is not intended. It's not ideal because I do not want to have that. For that purpose, there's another method which looks like from outside, and it does that by means of the call tree. So it just has a certain sample interval, which I can define. Let's take, for example, 1 millisecond, and check the timestamps. And by means of that timestamps and the call tree, calculates how much time every POU has taken. But how can I perform that from outside? This is a good question. You see that I need to configure one task, the profiler task group. By the way, there's a question here. I assume that the stats that the profiler is creating are minus the resources profiler using on the controller. Yes, correct. So these values that you receive from the measurement are not the absolute values for the overall system, but for the system plus additional code which is executed for the profiler. Therefore, don't look at the absolute numbers, but look at the changes, how this has changed during your development. Okay, coming back to the sampling. Sampling means that I need to check from outside. How can I do that? I can do that by using either another controller, but that's unhandy, or by using another core of my CPU. Perhaps you know that up to, I think, 2018, it was not possible to use the multiple cores with a CODESYS runtime system. But this is now possible. So we have in the CODESYS store, in the soft PLCs we offer there, some options in order to use multi-core possibilities. And exactly this is used here too. So there's a special sampling group, task group, generated automatically by the system in order to run on a separated core. And then from the other core, it can check the call stack of the core where the application is running. Perhaps I show you how this task configuration is realized. I double click here on task configuration. And there is now this task groups configurator. And you see that all my main tasks are inside that group named IC tasks. You have different options. Could be fixed pin to one of the CPU cores, but it could be as well sequentially pinned, free floating, which then is determined by the operating system on which CPU core is running. In any case, the sampling task group, it's defined and fixed pinned to a task, to a core which is not used for the application. This is what I've selected right now. Yeah, I can log in again. Download the application code now with the new sampling code. Takes again because the whole application is compiled and downloaded once again because we have really changed the code just by these few options. So an online change would not make sense. And we can execute the code once again. So this is a good time for getting some water, and then I can start the application once again. Okay, so at first step, I see nothing. What I can do is now refresh a snapshot, and you see here that these samples were already made 6,414 times. There were some failed samples. You can look up in the literature why failed samples may happen with this method, but it's quite normal. And if we refresh that sampling, then we will find out with the time and with the number of samples more and more accurate how long the main task, for example, and the PLC PRG is taking time for the execution. So this is a method which works on statistical measurement, not on an accurate measurement. So breakouts cannot be catched by this, but you get a very good look from outside. And again, here I can save a snapshot to sampling in order to compare it with other measurements, for example, the day before. Okay, there's a question: how much the footprint, megabytes, does the profiler consumes on the controller? This is a good question. I cannot give you exact numbers, but I would assume that it's below 5% of the total application code, but because you can check it yourself. As I did it before, you can manually insert the code, and this will be, of course, depending on how much you measure, but it's not much more than I did manually, so it's just a few kilobytes. But I cannot give you an exact number. Okay, refresh the screenshots, the snapshot once again. You see, we get more and more the PUs called into the measurement because we're just statistically checking them, not systematically. Okay, so coming back, switching out again, logging out again. There's a third possibility, which is now not a real measurement, but more or less a tool in order to see which code was covered during the measurement. This is, of course, as well a very useful information, especially when perhaps testing the application code, which we do in the last step. So I now activate the code coverage, go back to the settings, and can now define which of the PUs I want to check concerning the code coverage. Of course, I want to take all of them for the demonstration, and you see then here there's code coverage showed in the status line of the development system. Logging in again, I will receive an information on that. And again, I have to recompile completely. and to download completely because I have really changed the code. I've switched off the sampling, so the additional task group is no more needed. There is no instrumentation inside. However, there is as well some additional code put in order to do that measurement. Here we are, and as soon as we start the application, we will see that this code coverage, which is now 0% for all these POUs, will have different numbers. Yeah, and you see that, for example, simulation is now in a 76 percentage. During a certain phase, it will be stepping up in order to see whether I have really covered all the codes inside. And in case I want to check it directly inside the code, I can double click on it. So now you see it's changed to 92%. And I see all the green lines were already at least once executed and the red lines were not. Why ever? Now I can check by that tool why they were not executed. And this helps me again to avoid problems, to be sure that my code is well tested, and to find possible timing problems within the application. Good. We're almost done with the profiler. There's one more option I wanted to show you quite quickly. For that purpose, I just switch off profiling. I could delete the whole object in here. However, in case I'm logged in to the application, I have another option. And for that purpose, I just log in again. Let's assume I didn't activate the profiling, the instrumentation. However, I want to measure one or two objects within my POU. Can I do that nevertheless? Yes. The answer is quite simple, and I will show that. In the meantime, there is a question: what versions is the subversion profiler UML available, or is it special upgrade? The best is to check it on the CODESYS store. There you find the latest version and the version numbering. And what you can do furthermore is go to Tools, Package Manager, and there are all these packages listed. And in case there are updates, you see that by this information icon here. So there is a new version available, and you can see which version you have installed and which update you could benefit from. Good. Before I check the next question, I wanted to show you what I said before. Let's assume we are in the commissioning and we want to check just a few POUs. For that purpose, I have a new option right now, online profiler, and there's a profiler watch list, a new watch list. And it's quite simple to use it. I just take the object and drag and drop it in here, and you have immediately the measurement. So like a real-time view. And I can do other ones, and I immediately see, oh, wow, this is executed, but this is not. Probably this is just not called at the moment. So it gives me, again, a nice debugging and problem-finding tool for my daily work, for example, during commissioning. Okay, now let's check a question. What is the maximum number of function block instances of a function block within a single POU? What is the impact of instantiating 1000 of instances in a single POU? Can profiler provide some insights to it? This is a good question. Maybe we can postpone that. I'm not sure whether I can give you the right answer for that question. However, we will record that question and come back to you via email. Okay. Good. Coming back to the presentation, I see that 1.5 hours is almost finished, but we are already within the last part. So we have seen how the integration of the profiler is realized in CODESYS, which options we have, and how you can benefit from these measurements. We've seen the code coverage, in order to be sure what was checked. And yeah, this is as well a useful information for test automation.